One thing I want to get into before I talk about this episode's topic is something that you may have noticed in the previous video, and it has to do with purity. If you look closely, the function that we're passing to reduce isn't pure. Now, why is that? As I've said, one of the necessary conditions for a function to be pure is that it only operate on things that it was explicitly passed. Now, this function is only passed ACK and cur, but it operates, for example, on the type, but it's not given the type. It incorporates the type from the outside world, and so that's why this function is impure. The reason it's able to do this is due to a feature in JavaScript called Clojures. And I'm referring to a feature of the language, and I'm not referring to the programming language called Clojure with a J in the middle. I'm referring to a feature of the JavaScript language called Clojures. And that feature allows functions to access variables from the scope outside of which or outside their own scope, like the surrounding scope, as in this example, contains this type variable. And so this function, when it runs, has access to that type. Okay, you can make it more clear that a function is impure if you take it out of the context in which you run it. So let's say we had given this function a name and had declared it outside of that context. Now I think it becomes more clear. If you don't even look at the thread function underneath, and you simply say, okay, this is just a function. We don't even know what we're going to use it for yet. It's given ACK and cur, and then all of a sudden you're switching on a type. That's weird. You don't know what that type is. You don't know where it comes from. Same with isCall. It's not given this function, and yet it knows how to run it because the outside scope contains this variable, and so it simply incorporates it. So this is something to watch out for. Now, as I've said in the, I think, second video on purity, you can't always write pure functions. This is going to happen. So this is perfectly fine. I just wanted to point out that this is something that happened in the previous video. Okay, with that out of the way, I want to get to today's topic, and that is get and assoc. What you may have noticed is progressively throughout these videos, what we've been doing is we've been taking sort of standard JavaScript operations like greater than, plus, times, and we've been extracting them out into their separate little functions. And we haven't done that yet for some things. For example, we haven't done that yet for getting and accessing items in arrays and objects. So instead of using this gnarly bracket syntax, what I'd really like to do is turn this into a first-class function, and so then we can programmatically call this bracket syntax. And in line with the Clojure nomenclature, we're going to call that function get. I'm not sure if this may prove to be problematic on some platforms because get may well be a reserved JavaScript keyword, but I've run it in this environment and it seems fine here. You could pick another word for it if you run into trouble with this. Now what get is going to do is it's a very simple function. It simply takes some item, some collection that you want to access, and it's going to take a key. And then all you're going to return is the item at that key. And as you know, in JavaScript, this is going to work for both objects and arrays. So if your item is an object and your key is a string, that's going to work for objects. If your item is an array and your key is a number or an index, then it's going to work for arrays as well. But now what we can do with this is we can use this, for example, in our thread operators as a function. So that's the benefit of having this as a separate function rather than accessing stuff directly using the bracket syntax. And it also allows us to, for example, rewrite our last function here because now last has turned into get on that collection. And what index do we want to get from the collection? The collection's count reduced by 1. Let's see if this works. There you go. Okay, so much for accessing some item's key or index. Now to making changes. Now this is a bit of a paradigm shift because, as I've said, in functional programming, we want to avoid mutation. But we still want to make changes to objects and arrays at times, quite often, really. So what we're going to need to do is, instead of mutating an array, we're going to want to copy the entire structure and then make the change. And for this, again, in line with the Clojure nomenclature, the exact same function exists in Clojure as well. We're going to call it assoc, which stands for associate. And what this function is going to take as parameters is the item that you want to operate on, the key that you want to update, and the value that you want to update it to. And so now we're going to have to check, we're going to have to differentiate, is this an object or is it an array? We already have a function to check if something's an array that we called isCall for whether or not it is a collection. We may consider an object to be a collection as well, so the nomenclature may not be the best here. But for now, let's just stick with it. So we're going to say if isCall item, then it is an array. And if it's not an array, then we're going to assume that it is an object. Now this case is the easier case, I think. And so usually what you would do is you would say, the item at that key equals value. But that mutates the object. So we don't want to do this. Now, JavaScript provides us with this method called assign. And you may have heard of this function. Now, it's important to remember that assign only doesn't mutate, or it only serves the purpose of not mutating the item if we're passing as a first parameter a fresh new object. Because this first parameter will be changed. It's only the subsequent parameters that are not changed. Basically, what object assign does is you can pass as many arguments here as you want, and it's going to iteratively assign all the properties of each parameter to the first parameter that you pass in. So what we're going to pass in here is a new object with a key that has the same name as the key that we're passing in and the value. And I forgot, as a second parameter in the middle, it has to be in this order. So we're going to overwrite a new map, a new object, first with the item that we're given, and then with a new object that contains the key with the same name and a value. And what this is going to do is, first it's going to take everything from item, put it in the new object, and then it's going to take everything from this object and put it in the new object. It's not going to touch item, which is perfect because we didn't want to mutate item. So this is excellent. That's exactly what we need. And now what we want, what's missing is the case of the array. And I had to look this up. I found it on a website called peterbe.com. I'm going to put the link in the references. But it ended up being the exact same, only your first argument is an array and everything else looks exactly the same. Now, of course, the key in this case is going to be a number. And the reason this works is because arrays in JavaScript are also associative structures. And they just have numbers for keys when they're arrays. So that's the reason all of this works. Now, the way we're going to use this, I'm going to show you. Let's just run it. So let's say we have some object called foo. And we're going to say bar is bar. So this is our foo object. Now we can call assoc on it. And when we call assoc, we can now associate a new key. Let's call it baz and set it to 1. And so what you'll see here is now we get a new object that contains both the original entry and this new entry that we set. And also note that foo, the original foo, was not touched. So we've made a change to an immutable object by copying it and then making the change. And we get a brand new object in return. You can also overwrite an existing field. If we were to associate foo with bar, which it already has, then you're simply going to overwrite that. So you can use it for replacing existing fields as well. And let's say we have some array, and we want to try out assoc with that array. And now, instead of passing a string for a key, we're passing some index that we want to overwrite. So let's say I want to update the first element in the array. Then, and I want to set that to 5. Now our array is 523, but again, our original array has not changed. And so this way, now that you have get and assoc, you can programmatically and without dangerous mutations make changes to your arrays and objects.